All right, folks, welcome to week 2 of developmental psychology. Not a ton of business to cover. So this week we have chapters 3, 4, and 5. There was some confusion about the due dates for some of the assignments because the date listed was different from one of the descriptions. Always go with the date posted on the actual assignment when it says it's due, but I'll get those changed. But just to reiterate, journals are due Wednesday night. Discussions are due Thursday night. If it's a paper week, a week where you have a paper due, that's due Friday night, and then the quizzes are due Saturday night, all at 11:59 p.m. A pretty good job on your discussion posts and your journals. If you're going to cite something, just be sure to look up a little bit how to do those in-text citations and things like that. A few of you had some grammar, spelling issues. That was the main thing, especially on the discussion posts. Just remember, these are not like text messages. These have to have proper spelling, grammar, capitalization. Of course, some of you didn't make 2 responses, or maybe your response was a little too short. Like it should be more than just like, nice job, or even, I really enjoyed your post, nice job. Like you have to say something a bit more than that actually responds to their post. But other than that, pretty good. If you have any questions about your grades for the first week, give me a call, let me know. Give me a call, give me an email, send me an email, and I can try and explain more. All right, so for this week, week 2, we have chapters 3, 4, and 5 somewhere, chapter 5. So we've got our quizzes for 3, 4, and 5. We have week 2 journal, and we've got a week 2 discussion. Okay, so without further ado, let us get into this. Okay, let's see if we go one bigger, what that's like. All right, we'll see how this goes. Chapter 3, so this is basically infancy, development in infancy and toddlerhood. So you'll see by the objectives, describe newborn assessment, reflexes, states, and temperament. Describe physical changes in infancy and toddlerhood, as well as growth of the nervous system. Describe the growth of locomotion and fine motor skills during infancy. Describe the development of senses and perception during infancy. And describe the development of self-understanding and theory of mind. So obviously, that would be a little later. So we're going to go from a brain that has just come into the world and is just coming online, essentially. All this information is coming in. The first thing brain has to do, essentially, is learn how to control the body, learn how to lift the head up, sit up, crawl, move things, pick things up, put things to mouth, do drawing, playing with toys, grasping, all that stuff. Then eventually running and advancements in perception. At first, things are sort of very, as William James said, a blooming, buzzing confusion. As time goes on, infant brain starts to make sense of the world. This patch of color is this patch of color is that, this shape is this, right? Concepts, and eventually self-concept and a theory of mind, right? So we're going from no concepts to a concept of a self in one's own body and selves in other bodies, going from not being able to do anything, brain not being able to control the body, not really being able to perceive anything. Sensory information is coming in, but not really being able to make any sense of that, to being able to make sense of everything coming into through all the different senses, being able to control the body in all kinds of different ways. So a lot going on, and there will be an explosion of connections within the brain in this period, more so than any other time. All right, the newborn. Key questions. How do reflexes help newborns interact with the world? How do we determine whether a baby is healthy and adjusting to life outside the uterus? What behavioral states are common among newborn? And what are the different features of temperament? So temperament is kind of like personality. It's sort of like the beginnings of personality, or the basics of personality. Some new reflexes some newborns are born with, or all newborns are born with. A newborn is born with unlearned responses triggered by specific stimuli. That's, of course, just what a reflex is. Some have survival value. Some more so did in the past, right? So rooting, one of the rooting and sucking. Rooting is looking for a nipple. Sucking is sucking on anything that uh, makes its way into the baby's mouth, right? That's a good instinct for survival. Blinking your eye when something comes to jab your eye, that's a pretty good reflex. Other reflexes are developmental precursors to later voluntary motor behaviors, right? So stepping, that sort of reflex to step, to walk. There's a grasping is one that is a common one for if you put anything in a baby's hand, it'll grasp. So that's more of like a leftover thing when babies had to grab on to their furry mom's back to survive. But overall, we don't do a lot through reflexes, right? Our survival when we're little is not based so much on our reflexes, although we have a few and they are crucial, but based on what we learn. So when we're younger, before we can survive on our own, it's because of the community, our parents, and then later we're not so much reflex oriented, but learning oriented. Okay, so we can assess a newborn with something called an APGAR score. It assesses breathing, heartbeat, muscle tone, reflexes, and skin tone. Each one is scored from 0 to 2. And if you get 3 or less, your baby is in very serious danger of dying. 7 or more, good physical condition. There's also something called the Neonatal Behavioral Assessment Scale, or the Brazelton's Neonatal Behavioral Assessment Scale. This is 28 behavioral and reflex items, assesses 4 systems: autonomic, which is body regulation, like breathing, things like that; motor, ability to move the body; state, maintaining states like alertness and interacting with people. States of a newborn are basically alert, inactivity, waking activity, crying, or sleeping. And that's what you get for a few months from a newborn. Sometimes it's said that the first 3 months of a newborn's life are like the 4th trimester, because newborns, human babies, are born more prematurely than in many species, because our brains got too big to fit through the vaginal canal, so we have to be born kind of early, which means we do not a lot for a while. Crying, newborns do a lot of that. There's the basic cry, the mad cry, and the pain cry. Basic cry starts softly and builds in volume and intensity, often seen when child is hungry. The mad cry, more intense and louder. Pain cry starts with a loud wail, followed by a long pause, and then gasping. Newborns sleep an average of 16 to 18 hours a day. They have sleep cycles of 4 hours, where they're asleep for 3 hours and they're awake for 1 hour. By 6 months, typically, it is about 10 to 12 hours a night. Of course, everything we say throughout this whole course, there's always a caveat of these are averages. So this is every individual is unique, and there may be people who vary quite a lot from these averages. REM sleep is about 50% of newborn sleep, and it goes down to about 33% by 12 months. So REM sleep stands for rapid eye movement. It's the portion of our sleep at night in which we dream. So newborns are dreaming a lot. There's a lot of activity going on. So our sleep cycle goes in these waves. So it goes from light to deeper, 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 deepest. And we come back up to lighter sleep. And then at the top, we do REM sleep. We dream for a few minutes, and then we come back down. And we go through 4 to 6 or so of those cycles per night. Okay, co-sleeping. This is when a baby sleeps with the parents in the parent's bed. Really, this is sleeping for basically all of human history and in much of the world. Babies sleep with their parents. Putting a baby in a crib away from the parents is a very unusual culturally. Very few cultures do it. Western culture is one of the few that does that. So outside of North America, many parents engage in co-sleeping. Research does not support the idea that it makes the child uh, less self-reliant. So some people worry that if you have the child with you all the time, you're kind of like spoiling the baby, which is not really a thing. You cannot spoil a baby. Research suggests that co-sleeping is dangerous only when parents smoke, drink, or sleep with babies in sofas or chairs. You don't want to accidentally smother your baby, essentially getting too drunk or sleeping in a chair or something. Obviously, secondhand smoke is not good. Co-sleeping facilitates breastfeeding. A lot of times, mother and baby can get more sleep if the baby can just quickly nurse and everyone can get back to sleep. There is little evidence about the long-term effects of co-sleeping. Future research should consider if it is a well-established cultural practice, how it occurs, and why parents choose to do it. SIDS, or sudden infant death syndrome, is when a baby just dies in its sleep. We don't cause is mysterious, but some risk factors are premature or low birth weight, parental smoking, child overheating, sleeping on stomach. African American, Native American infants often sleep on their stomach. They seem to have a higher risk of this phenomenon, but they may be due to other factors as well, of course. Okay, talking about temperament, sort of the first beginnings of personality. Yes, infants are born with temperament. Some infants come into this world and are pretty chill, and God bless those parents. They get lucky, and infancy is just fun and joyful. Other parents, their baby will scream and cry pretty much 24/7. So, according to Rothbart, there's three broad sort of temperaments. The first is generally happy, active, vocal, and seeks stimulation. That's sort of like extroversion, you might say. Another would be sort of the negative affect personality trait, anxiety, depression type personality traits. So angry, fearful, frustrated, shy, not easily soothed, right? How easily does a baby calm down when you pick it up? If it does get disturbed, how easily does it get disturbed? How easily does it calm down? These are sort of basic elements of personality. And third, focuses attention, is not easily distracted, or can inhibit impulses. So even at a very young age, you see differences in things like impulse control and ability to kind of focus on a task, or is the child just sort of more mesmerized by things in the environment? Studies suggest that temperament tends to be somewhat stable from infancy through adulthood. Temperament predisposes but does not always guarantee later personality traits. Parents can nurture children to behave in ways somewhat different from their temperaments. So there's a slide here later about how Chinese babies have different temperaments. They're more kind of stoic. They show less emotion, even at 11 months old. So obviously, parenting has some effect on temperament, but temperament is sort of the foundation that is determined genetically and by things like even early environment and health and things like that of the mother, and how is there any trauma, medical trauma in the first few days, things like that can also affect temperament. Okay, hereditary and environmental conditions, environment, cultural and ethnic factors. Toddlers in Asia have greater effortful control, but lower levels of positive emotion than European children. Absolutely fascinating how there can be such a dramatic difference at such a young age, and really fascinating to think about these two cultures, both great in their own rights. And of course, we're glossing over, there's a lot of different cultures within East and West, but these cultures did evolve very differently, very different cultural and religious traditions. And you see that's a really profound difference in personality, right? More self-control, right? Think about someone who's like meditating, but maybe less like happiness, laughter, and bubbliness, but more maybe deep peace or something like that, or ability to control sadness. That's really fascinating stuff that we probably need to understand better as we move forward as a species. Parental characteristics, how responsive a parent is, right? So emotionality If the parent is responsive, it's going to reduce that kind of negative emotionality. Depressed mothers encourage fearfulness, right? So parents' emotions and parenting style will pretty dramatically affect the child's. Okay, let's cover activity. 3.2, physical development. Key questions. Oh, one, that is not the right number. How do height and weight change from birth to 2 years of age? What nutrients do young children need? How are nutrients best provided? What are the consequences of malnutrition? How can it be treated? What are nerve cells and how are they organized in the brain? And how does the brain develop? Sorry, just checking something real quick. Okay. Growth is more rapid in infancy than during any other period after birth. Infants double their weight by 3 months. Infants triple their weight by 1 year. Average is not the same as normal. Children of the same age vary greatly in their heights and weight. Height depends largely on heredity. Of course, height and weight can be influenced by things like mother's use of cigarettes during pregnancy and nutrition as an infant, things like that. But there's obviously a large extent of heredity. You are what you eat. Rapid growth requires young babies to consume large amounts of calories relative to body weight. Breastfeeding is the best way to ensure proper nourishment. Bottle feeding has advantages and disadvantages. Obviously, it's easier and more convenient for mothers who need to work and things like that. But even the best formula milk is not as healthy for a child as breastfeeding is. Malnutrition. Worldwide, about 1 in 4 children under age 5 are malnourished. Malnourished children tend to be small for their age due to inadequate nutrition. Malnutrition can cause substantial and potentially irreversible brain damage. Malnourished children are listless, quiet, and inactive. I mean, this is kind of crazy. I mean, of course, this is, thinking about all the children in Gaza who are starving right now, but 1 in 4 children are malnourished, and malnourishment can cause irreversible damage, which that's really sad. These characteristics call less urgent attention to the children's needs, meaning that they're quiet and inactive. About 11% of U.S. households are food insecure, unfortunately. So the brain and the nervous system consist of cells known as neurons, which consist of a cell body, dendrite, axon, and terminal buttons. Terminal buttons release chemicals called neurotransmitters. So hopefully you all remember this from your introduction to psychology class. You've got your neuron, it's your cell, and it's got a long little tail, and that's how it sends signals, and it's got other thingies. Let's just pull up a picture of that. So here's our neuron. Oops. This is our main cell body. This is the axon. So this neuron is sending signals to other neurons, and there's other neurons connected to all these other parts up here. All right, so it's receiving signals from, so each neuron has about 10,000 connections. And we've got about 80 billion neurons, so that's a lot of neurons, a lot of connections. So we're born with all our neurons, but what's happening is these neurons start to make connections as we grow. Every time we learn something, every time we experience something. So if you can think about, like, imagine a seed being planted in a pot of dirt, and that seed is like a neuron. And if you've ever pulled a plant out of a pot of dirt that's been in there for a while, and you just see those roots going everywhere throughout it, that's eventually what a brain becomes like, connections everywhere. But it takes time for all those to build up. Okay, the cerebral cortex is the outside part of our brain, the wrinkled surface of our brain. That's the sort of extra, our brain is wrinkly because it's sort of trying to jam as much brain as it can into our skull cavity. That's kind of what makes us as humans. Hemispheres refers to the 2 halves of the brain, which do have slightly different functions. in terms of like verbal and spatial intelligences. And the corpus callosum is a thick band of neurons that connects the two parts of the brain. As we get older, we actually get better at using both parts of our brain for various tasks. Okay, so after 3 weeks of conception, the neural plate forms. By 28 weeks after conception, the brain will have all the neurons it will ever have. That's not 100% true. We actually can make new neurons. We're learning that now, but that's to a certain extent true, or largely true. Neurons migrate and become positioned into the 6 layers of the mature brain. In the 4th month of prenatal development, axons begin to form the fatty sheath myelin. So that long part that sends signals out is covered by a kind of insulation called myelin. And that process of myelination happens throughout childhood into early adulthood. The number of synapses we have actually peaks at 12 months. So that first year, we have all these neurons. We're born with our 80 billion. First year, it's like an absolute explosion of connections in our brain. And then what happens is over time, as we start to use concepts more to understand the world, and we start to organize information, we start getting rid of certain connections, right? We start to sort of focus on the connections that we learn over time are more important, right? So you can imagine a newborn baby, it doesn't know what's important and what's not important. So it's just imprinting everything. And then gradually over time, it learns what the most important things are, so it can let go of certain connections and strengthen others. Electroencephalography is an electroencephalogram is a way of measuring brain electrical activities through nodes placed on the scalp. It's not super precise because it just measures electrical activity at the surface of the brain. An fMRI tracks blood flow to different parts of the brain. Again, not super precise, but these are ways which we can get some sense of what's happening in the brain. 5 general principles of brain specialization. Specialization is evident early in development. Specialization takes 2 forms, focused and trigger specific. Different brain systems specialize at different rates. Environmental stimulation is necessary for successful specialization in normal brain development. Experience expectant growth. That is a process by which the wiring of the brain is organized by experiences that are common to most humans. And then experience-dependent growth are changes in the brain that are linked to unique experiences, not specific points in development, right? So basically, that's just kind of the distinction between things that essentially happen to all humans in the process of their development. Like all humans will get exposed to other human voices, right? And that will kick into gear that process of language acquisition, whereas not all humans will experience a particular unique trauma maybe, or a particular event in their life that may affect them a lot. Okay, 3.3, moving and grasping, early motor skills. Locomotion. By 7 months, infants can sit alone, meaning sit up alone. Toddling. At around 14 months, toddlers may stand alone briefly and walk without assistance, but they are unsteady. So again, there's a wide range here. I mean, you have some babies that are, walking by 1 year, and some that are still crawling at 2 years. Some of this just has to do with infant preferences. Some don't mind crawling, some really don't like it, so they learn other ways of getting around. And so there's a lot of different reasons why it can happen. According to dynamic systems theory, instead of simple maturation, motor development involves many distinct skills that are organized and reorganized over time to meet specific demands. So physical stimulation, climbing, running, jumping, little games, itsy bitsy spider, went up the water spout, all these things are really important for children to develop different parts of their brain. Walking skills must be learned separately and then integrated with other skills. Differentiation and integration are 2 parts of this. Mastery of component skills is differentiation. Combining components into the sequence needed to accomplish a task is called integration. Unsupported, independent walking occurs usually between 12 and 15 months. Cultural practices can accelerate or delay early stages of Motor development. Here it says in some traditional African cultures, children receive training to sit and walk at younger ages than in Europe and North America. Swaddling, a practice in some Central Asian countries where you wrap a baby up in a blanket very tightly, can discourage motor development. So, depending on the culture, if the parents have to walk around a lot all day and they keep the baby swaddled, that could potentially discourage motor development. Fine motor skills. Fine motor skills are associated with reaching, grasping, holding, and manipulating objects. 4 months, infants clumsily reach for objects. 5 months, they coordinate movement of the two hands. 2 to 3 years, they can use zippers but not buttons. Tying shoes is a skill that usually develops around age 6. Handedness, preference for one hand over the other becomes stronger and more consistent during the toddler and preschool years, influenced by both heredity and environment. Many cultures have viewed left-handedness negatively. Coming to know the world, perception. Key questions. Are infants able to smell, taste, and experience pain? How well do infants hear? How well can infants see? Can they see color and depth? How do infants coordinate information between different sensory modalities such as vision and hearing? Newborns have keen senses of smell, taste, and touch. Smell evolutionarily is our oldest sense. It's the sense that signals go most directly to the brain. So smells can evoke the most powerful emotions the most quickly, even in humans. Taste, salty, sour, bitter, sweet, changes in mother's breast milk are aspects of touch. Tastes are relevant for children. Reflexes and other movements are part of touch for infants. Infants' pain cries, sudden high-pitched wail in response to apparent pain-provoking stimuli, suggests they experience pain. Obviously, everyone knows that infants experience pain. If you've ever been around one, as do animals, it's always a challenge to know what another being experiences, right? Even if we have a boyfriend or a girlfriend, we may not know what they experience, or a best friend, right? Because we all have unique experiences. It becomes more challenging when we're talking about infants or animals because they can't necessarily use language to tell us. So there can always be a tendency to dismiss the pain and the experience of other people. Infants certainly experience pain from all indications. They have all the neural hardware. They have all the external reasons to believe that they experience all those things. And it would be very, from an evolutionary perspective, it would be not very adaptive if infants didn't experience pain. Startle reactions suggest that infants are sensitive to sound. Infants hear less well than adults. They hear pitches best in range of human speech, neither high nor low, and differentiate consonants from vowels. They prefer pleasant more than unpleasant melodies and can remember songs. By 4 months, infants can recognize their own name. Right? So with all these things, infants can hear sounds, but to some extent, imagine you go to another country, you don't know the language at all, right? So, but at least as an adult, you go there and you know there is such a thing as language, and you know that people are trying to convey certain ideas, and you have ideas. For an infant, they don't know that there is such a thing as language. They don't know that sounds have meaning, right? So all those things take time for the brain to gradually learn. Every day it's exposed to these different sounds, and it can gradually start to hear individual words and learn individual words. Newborns respond to light and track objects they can see when they're first born. At 1 month, they can see at 20 feet at what adults see 200 to 400 feet, meaning they can see as well, right? By 1 year, infants' visual acuity is the same as that of adults. Newborns perceive few colors until their cones start to function at about 3 to 4 months old. Depth perception. So there's visual cliff research. By 6 weeks old, infants will react with interest to differences in depth. Their heart rate will raise. Right? So if you have a newborn infant and you walk over a glass floor, they won't necessarily notice anything, but by 6 weeks they will, right? By 7 months, they show more fear than interest at the cliff's depth, at the cliff's deep end. And fear of depth seems to develop around the time that babies can crawl. Perceiving objects and faces. Perceiving objects involves interpreting patterns of lines, textures, and colors. Object perception is limited in newborns, but develops rapidly in the first few months. By 4 months, infants use several cues to discern the stimulus is an object. Elements that move together, similar colors and textures, aligned edges. Newborns prefer to look at moving faces, suggesting an innate attraction to them. By 4 weeks, infants track all moving stimuli, including faces and non-faces. By 6 and 12 months, a prototype of a face is fine-tuned to reflect familiar faces, which they prefer viewing. By 7 to 8 months, infants process faces similarly to adults as a unique arrangement of features. So faces is something that we actually have dedicated parts of our brain specifically to processing faces. Another interesting thing about sort of perception in faces is there's actually a diagnostic test where you can assess autism in infants by putting a picture of a face and a picture of a complex geometrical pattern, and the autistic babies will look longer relative to the neurotypical babies at the geometrical pattern rather than the human face. So there is variation in ability to perceive faces and interest in faces. Integrating sensory information. Infants visually recognize objects they previously only touched. Infants soon begin to perceive the link between visual images and sounds. Intersensory redundancy. Simultaneously available multimodal sensory information. Infants perceive best when sensory information is redundant. Why? Brain regions specialized for a specific sense are not yet developed. Okay, now we're getting a little older, becoming self-aware. So to understand self-awareness, we have to understand a little bit about what a self is, right? So this is a little bit of a confusing point for most people because we think of ourself as a thing, right? Sort of can think of it as the soul model of a self, right? It's some sort of metaphysical entity. It's who we are, and it's sort of located somewhere within us, and it's this sort of very real thing. It's because we experience it as being very real. In Eastern philosophy, it's a common understanding that the self is what they would describe as an illusion. What does that mean? The self is an illusion. Well, in modern psychology, we don't specifically talk about the self as an illusion, although we can. But what we do talk about is the self essentially being a concept, right? So when we say, what is a self? Well, a self is a concept. Where does it exist? It exists in our head, right? It's just like we have a concept of what a human is, we have a concept of what a mother is, we have a concept of what a father is, what a dog is, what a cat, what a house, what a car. All these things are concepts based on our experience. So we also have a concept. The ultimate concept is our self-concept. It's a concept that is the most relevant, most familiar, organizes the most information for us, right? So eventually we develop a self-concept. I am American, I am Black, I am white, I am Hispanic, I'm short, I'm tall, I'm pretty, I'm smart, I'm talented, I'm good at this, I'm not good at this. This is my family, these are my friends, I live in Ohio, I live in California. All these different things get sort of, we gradually build up our self-concept over time. Okay, so when do children begin to realize that they exist, right? So famous quote from William James that to a newborn child, he said, the world is a blooming, buzzing confusion. Infants experience something when they come into the world, but you have to try and understand what is experience like before you have a concept, right? So say you see your mother's face, well, you don't have the concept of mother, you don't have a concept of a male or a female, you don't have a concept of a person. You see light colored patches, right? If your mother's white or if your mother's black, you might see a dark colored patch. against whatever the background is, a light or dark background, right? You look at your mother's face, and you see, different color patches and where the eyes are. You see, maybe you see, if you're looking at your father, maybe you see facial hair. Does your mother have dark hair, light hair, long hair, short hair, right? But you don't have the concept of hair. These are just squiggles and lines that you see, right? So when does a child begin to have an idea that, okay, here's an object, this is my mother, it exists? Well, it's going to take longer for us to have that concept of ourself because we don't directly perceive ourselves, right? So we're going to have other concepts first, but gradually we start to get a sense of, this is myself, this is my family, my house, my birthday, all that stuff. What are toddlers and preschoolers' self-concepts like? When do preschool children begin to acquire a theory of mind? Theory of mind is essentially the idea that we can conceptualize another person's thoughts, right? We do something when someone leaves the room, like a child may do something naughty when the parent leaves the room because they realize, okay, the parent can't see me if they're not in the room, right? Other animals can do that as well, social animals. Origins of self-concept, there's something called the mirror test. And to do that, you would put a red dot on the child's nose and put it in front of a mirror. If the child reaches towards the mirror to touch the red dot, the red spot, no sense of self. If the child reaches towards their own nose to touch the red spot, they have a sense of self. And we do this with animals, and there have been a handful of animals that pass the mirror test. Toddlers look more at photographs of themselves than photos of other children. Toddlers refer to themselves by name and use personal pronouns like I or me. Preschoolers describe the self in terms of possessions, physical characteristics, preferences, and competencies. So by the time children are able to use language, they have some kind of sense of self. How early, it's hard to tell because, the mirror test is a pre-language test, right? Maybe it is even before that, but children can't move well enough to do it. So there's some questions, but really it's sort of a red herring of a question because it's going to be pretty early. They have some very vague, loose sense of self, and it's going to continue to develop over time, right? People in their 40s can develop a more complex sense of their self, a deeper understanding, and continue to attach new concepts to our sense of self. Okay, I think this is our last topic, theory of mind. Theory of mind is a naive understanding between mind and behavior. Develops in 5 phases. Desire. By age 2, children understand that people have desires and that these desires cause behavior. Different beliefs. Child begins to hold beliefs that differ from another child's. Different states of knowledge. A child is aware that he may possess knowledge. Another child does nothing or does not, is what that should say. Belief. By age 4, children understand that behavior is often based on a person's belief about events and situations. And emotion. Children understand that people may feel one emotion but show another. Okay, summary. Now that the lesson has ended, you should have learned how to describe newborn assessment, reflexes, states, and temperament. Describe physical changes in infancy and toddlerhood, as well as the growth of the nervous system. Describe the growth of locomotion and fine motor skills during infancy. Describe the development of senses and perception during infancy. Describe the development of self-understanding and a theory of mind. Okay, that is chapter 3, all about infants and a little bit about toddlers. All right, we'll do the next chapter in the next